Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 6 to 10 of the January 2019 Algebra 1 New York Regents exam. Alright, let's take a look at question number 6. In question 6, we're going to be looking at how to apply the factoring of trinomials technique to an area problem. Question 6 reads, the area of a rectangle is represented by the quadratic expression 3x squared minus 10x minus 8. Question, which expression can also be used to represent the area of the same rectangle? Okay, so let's just give ourselves a visual representation of what's going on here. So we have a rectangle, and the area is given by the expression 3x squared minus 10x minus 8. And from geometry, we know that the formula for area is length times width. So what binomial expressions can we use to represent the width of this rectangle and the length in such a way that when we apply this geometry formula, area is equal to length times width, we will end up with this quadratic trinomial? Now, there are two ways you can solve this problem. You can simply just multiply each and every one of them to see which one generates this quadratic trinomial upon simplification, or we can factor. Okay, so in this presentation, we're going to be going over how to factor trinomials. So we're going to go over the process in detail. All right, so let's see what we have here. We have the quadratic trinomial 3x squared minus 10x minus 8. Now we're going to be using a factorization method known as the AC method or the X game. There are other methods that can be used to factor quadratic trinomials, whichever one you feel most comfortable with. Feel free to employ that method, okay? So the X game is as follows. What we'll do is we're going to extract A times C and B from the quadratic trinomial. Alright, so as we can see, it's already in standard form. Basically, we have the terms ordered in descending order of degree. So degree 2 term, degree 1 term, and degree 0 term. So the coefficient of the highest degree term is A. So A is 3, B is negative 10, and C is negative 8. Alright, so let's write it down. A is 3, B is negative 10, and C is negative 8. Alright, so AC is a product of 3 and negative 8, which gives us negative 24. And then B is negative 10. Alright, now we're going to play the X game. Now, to play this game, we're going to think about two numbers that multiply to give us the top, negative 24, and add to give us negative 10. Okay? That will enable us to express this quadratic trinomial as a quadratic with 4 terms, and we can split it down the center and factor by grouping. Now, to help us to determine what those two special numbers are that can enable us to factor by grouping, we're going to write down all the product of integers that yield the product 24. Okay, so what two numbers multiply to give you 24? What's two integers? 1 times 24 gives us 24. 2 times 12. Does 3 go into 24? Absolutely. 3 times 8. Does 4 go? It certainly does. 4 goes into 24. 6 times 5 doesn't go. We have a complete loop. Alright, so which pair of numbers gives us 10? Let's focus on the number first before the sign. Alright, so we have 1 and 24 gives us 23 or 25. That's no good. 2 and 12 gives us 10, which is good. 3 and 8 gives us 11 or 5. 4 and 6 gives us 10 or 2. So we have two candidates here, which makes this problem a little bit complicated. It's either 212 or 46. So which one are we going to use? Let's try 212 first and see if we can play with the signs in such a way that this X game works. If we can't figure it out, then we have to resort to trying out 46, okay? So the sum is negative and the product is negative. If the product is negative, that means the signs have to be different. If the sum is negative, that means the bigger number must be negative. Or both of them is negative, which is not applicable here. Alright, so 2 times negative 12 is negative 24. Excellent. And 2 minus 12 is negative 10. So that works perfectly. Alright, so the desired pair that we are going to be using for factoring this quadratic trinomial is 212. Now what we're going to do is replace the middle term with these two numbers. So we will have 3x squared, and instead of negative 10x, we'll replace it with the two numbers we just got, plus 2x minus 12x. So we insert the numbers in the middle and then just put x's next to each of them. Alright, now we have four terms. We can now factor by grouping. We'll break it down the center and factor by grouping. Now, let's see. From the first two, we're going to factor out the greatest common factor, and then from the next two, we will also factor out the greatest common factor. Now, for some of us, we can easily just inspect and see what the greatest common factors are, but let me show you the steps that results in that. Okay, so we'll break this down. We'll have 3 times x plus 2 times x. And then here we pull out minus. If we break down 12, 12 can be broken down. Let's use a factor tree. 2 goes into 12 6 times, and then 2 goes into 6 3 times. So it's 2 times 3, 2 times 2 times 3. And then if you break down 8 into product of factors, 2 4, 2 2. So it's 2 times 2 times 2. So for 8, we're going to have 2 times 2 times 2. Alrighty? Okay. Now, from the first two, well, we can group this together in the parentheses. From the first two, we want to pull out the LCD, the greatest common factor, not the LCD, the GCF. The GCF, we have x and x that are common here, so we're going to factor that out. So we factor out the x. And when we factor out a common factor, what we're doing is we're dividing by that factor. So this x is divided out to be a 1, this x is divided out to be a 1, and we are left with 3x plus 2. Alright, now on the right side here, we bring down the minus. So now that we are factoring out a minus, you want to proceed with caution, okay? So we'll put a parenthesis here. Whenever you factor out a minus, what happens is that this sign changes to the opposite. So this plus, this minus actually switches into a plus because I pulled out a minus there. Alright? Now what can we factor out? 2 2's from both sides of this sign. So 2 times 2 is 4. So we have 4 on the outside. So now what we have done is we just factored out 2 2's. So 2 divided here 1. That's a 4 factored out. And then over here 2. That's another 4 factored out. Now we're left with, oh, there should be an x right here. Let's put an x here. So we're left with 3x plus 2. Okay? Alright, so now we're going to solve and check and see how we're looking. The quantities in the parentheses, we'll ask ourselves, are they the same? And the answer is yes. So 3x plus 2 and 3x plus 2 are the same. So we factored it out into its own parentheses. 3x plus 2 and 3x plus 2. Because these two quantities here are identical. Alright, and then what's left? We are left with x minus 4. What do we do with that? We group them together in their own nice little parentheses. And that, ladies and gentlemen, is the factored form of the quadratic trinomial. Alright, so we can think about, we could call 3x plus 2 the length, or x minus 2 the width. It doesn't really matter. And then we have the area being equal to this desired expression, 3x squared minus 10x minus 8. Alright, so we now know what the length and the width are. So let's write it here. 3x squared minus 10x minus 8 is equal to 3x plus 2 times x minus 4. And our answer is option number 1. Alright, in question 7, we're going to see how to identify functions. We have multiple representations here. It says, number 7 says, which relation does not? So you want to be careful. We want to look for which one does not represent a function. We have a table, we have an equation, we have a graph, and we have a map. Now for the first one, we're going to look for repetitions in the x's. So look at the x's. Are there any repetitions? No. So since there are no repetitions in the x's, it means it's a function. So no repetitions in the x's imply that this is a function. Alright? So we're looking for what's not a function, so we eliminate option 1. Down to option 2, we're going to use something called the vertical line test. Okay, so if you draw a vertical line and you sweep your vertical line past the entire domain of the graph, if it intersects exactly once, then you know that it is a function. It passes the vertical line test. So you can see here that this vertical line intersects this graph at exactly one point at multiple places. So once, it's just one point of intersection every single time. Okay, so let's do some more. So that's one point of intersection, one point. It cuts just once. Now what does that mean? It means that this function passes the vertical line test, which means it is a function. Okay, so this is a point of intersection here. The first one, let's go ahead and try it. So the first point of intersection, just once. Everywhere in the domain, it just intersects exactly once. Okay, so let's say you had a function that looks something like this. This will fail the vertical line test because if you draw a vertical line, it's going to intersect at more than one point. So this is not a function, but this graph we have right here is an absolute value function, is a function because it passes the vertical line test. Okay, so passes the vertical line test, or the VLT, vertical line test. What does that mean? It means that this is a function. And that's not what we're looking for. We're looking for something that's not a function. Okay, so let's go to option 3. So we have a function right here. All we do is we look at the power of the y and also what's around it. Y doesn't have a power, so the default power is going to be 1. Alright? So if your y, your output, has an odd power, or it doesn't have, or does not have absolute value brackets, then it is a function, and that's the case here. Okay, so for 3, y has an odd power. If it has an even power, then it's not a function. Okay, y has an odd power and no absolute value brackets. Absolute value brackets. Alright, so you have an odd power and no absolute value brackets. What does that tell us? That tells us that your equation represents that of a function. Remember, we're focusing just on the output here, just the y. Alright, so let me give you an example of something that's not a function. If you have something like this, y squared is equal to 3x plus 1, this is not a function because you have an even power. Or if you have absolute value of y plus x equals 4, this is not a function because you have absolute value brackets around the y. Okay, this is not what we want. We want something that is not a function. Question 4. This is a map. An easy way to attack this problem is to convert it into form 1, which is a tabular format. So let's just convert this into a table real quick, and then it'll be easy for us to determine if it's a function or not just by looking for repetitions in the inputs. Okay, so we are going to call our inputs the x's and our outputs the y. Okay, so what do we have here? We notice that 1 goes to 4 and then another 1 goes to 5. That's already a problem. Why is it a problem? Because we have repetition in the x's. And then 2 goes to 6, 2 goes to 7. That's another problem. 3 goes to 8, and 3 goes to 9. Ladies and gentlemen, this is not a function, okay? We have repetitions in the x's, in the inputs, so that means it's not a function. A function assigns every input to exactly one output. You cannot have one input being assigned to more than one output. Okay, so one input, one output. So this is not a function, and ladies and gentlemen, the answer for question number 7 is for a relation that is not a function. All right, let's take a look at question number 8. In question 8, we're learning how to identify the properties of equality given the steps that a student executed. All right, so question 8 reads, it says, Brittany is solving a quadratic equation. Her first step is shown below. So this is the original problem, 3x squared minus 8 minus 10x equals 3 times the quantity 2x plus 3. And then step 1, she has 3x squared minus 10x minus 8, which is equal to 6x plus 9. Question, which two properties did Brittany use to get to step 1? So what we're going to do is take a look at the problem and step 1 and see if we can identify what the difference is. Okay, so 3x squared here, negative 8 here, negative 10 here, negative 10 here, negative 8 here. So it looks like she has interchanged terms. She has moved 8, she moved 8 over here, and then she moved negative 10x over here. Alright, so she basically moved terms on the left side. And then on the right side, the 3 in the parentheses here is no longer present here. So she must have carried out an operation, multiplied 3 times 2x to get 6x, and 3 times 3 to get 9. Alright, so which two properties explain the movement of terms and then the multiplication of a coefficient into quantities in a parenthesis that it's been multiplied by? So here we have move, and here we have multiply. Alright, so let's review our properties of equality real quick and then see which one applies to this particular scenario. Addition property of equality. If A is equal to B, then when you add a number to both sides, the equality is preserved. A plus C is equal to B plus C. Alright, she didn't add anything to both sides of the equation, so it's not the addition property. Commutative, now this is a big word. If you think about the word commute, what does that mean? If your parents are commuting to work, commute means to move, okay? So commutative property of addition just basically means that you can reverse the order of a sum or difference. Alright, so commutative property of equality basically implies that A plus B is equal to B plus A. Alright, so here what we have, you got to be a little bit careful here. The signs weren't changed. She just reversed the order here. So you basically have negative 8 plus negative 10x, and then she rewrote it as, so it's negative 10x plus negative 8, and then if I don't put the parentheses there, it's just negative 10x minus 8. Alright, so what she did is she reversed this addition that's going on right here. The addition here is the addition of two negative terms. So commutative property is applicable to the left side of what she did. Now, what's the multiplication property of equality? Well, it says if you have A is equal to B, then if you multiply both sides by the same thing, the equality is preserved. AC is equal to BC. In this particular case, no multiplication to both sides happened. It was a different kind of multiplication on just the right side here. So it's not this kind of multiplication we're talking about. Distributive property of multiplication, over addition. If you take a look at what happens right here, we have a multiplication over addition. So we had the addition operation here, and 3 was multiplied across these two terms that have been added to each other. So that accounts for the difference between the problem and the step 1 on the right side of the equation. All right. So the two properties that Brittany used are properties 2 and 4. Answer to number 8 is option number 4. All right, let's take a look at question 9. It says the graph of y equals 1/2 x squared minus x minus 4 is shown below. The points -2, 0, and 0, -4, and 4, 0 lie on this graph. Okay, so which points can determine the zeros of the equation? Now, you want to remember the following. You want to recall that the zeros are the x-intercepts. There are two types of intercepts you have in Algebra 1. You have the x and y intercepts, but the zeros are just the x-intercepts, okay? So in this graph, this is the y-intercept where y is 0. This is given by 0, -4. All right, this is point B. And then we have another intercept here, 1, 2, 3, 4. This is 4, 0. This is point C. And then we have another point here, -2, 0, 1, 2. And that's point A. Now, which of these intercepts are on the x-axis? Those are your zeros, all right? So the intercepts that are on the x-axis are A and C. So the points 4, 0 and -2, 0 represent the zeros, okay? So this is 1, 0. And then the other 0 is point A, which is -2, 0. So A and C are the zeros of the equation. We have to exclude point B because it is not a x-intercept. So these are your x-intercepts, and those are your zeros. All right. So that's how you find zeros using the graph of a function. All right, let's take a look at question 10. In question 10, we're going to be learning about how to transform quadratics. Question 10 says, given the parent function, f of x equals x to the third, the function g of x equals x minus 1 to the third minus 2 is the result of a shift of f of x. So which of these describe the shifts of this to yield that function right there? Before we get started, let's do a real quick review on our shifts, our transformation of functions. So recall the following. If you have a function composed with x minus h, this represents a shift h units to the right. Now this is kind of interesting because you have a minus here, and you would think intuitively that when you compose a function with x minus an integer, it will cause a shift to the left, but it's actually backwards. Okay, so f composed with x plus h, in this case you have a shift h units to the left. Okay, so whatever is grouped with the x, you're looking at the opposite. Okay, the opposite effect, that's what's going to happen. But when you have a function and you add a number to that function, that's going to be a shift k units up. And then when you have a function and you subtract a number from that function, there's going to be a shift downwards. Okay, shift k units down. All right, so let's take a look at what the situation is that we're dealing with in this problem. Okay, all right, so in this problem we have g of x equals x minus 1 to the third minus 2. So let's write down our general formula right next to it and see what's going on. So generally we have g of x. This is going to be x minus h, actually a function of x minus h. Well, let's adapt it here. So it's x minus h to the third plus k. Okay? Alright, so let's break down the two transformations that are happening here. The first one is we have g composed with x minus 1. In the original function x to the third, the x was replaced with x minus 1. So that is equivalent to this right here. So if you have x minus 1, guess what that means? G of x minus 1, which is basically x minus 1 to the third. This indicates a shift in the x direction. But is it to the left or to the right? Is a shift 1 unit to the right, as indicated here. Okay, if you have x grouped with a number, you do the opposite of what the sign in the center says. And then we also have g of x, the function. So let's make a real quick correction here. This is f. We had f composed with x minus 1. And then we also have f of x and a number subtracted, f of x minus 2. Do you know what this causes to happen if you have f of x minus 2? When you subtract a number from a function, that causes the function to shift either up or down. But if it's minus, it's going to shift actually 2 units down. Okay? So shift 2 units down. So basically, the number that you're adding to the function as a whole represents your vertical shifts. So this is up and down. F of x minus 2 applies to this particular scenario right here. So the function minus a number will result in a vertical shift downwards. Okay? But when you're composing a function with x plus or minus a number, that's a horizontal shift, and then minus goes to the right and positive goes to the left, and then for vertical shifts, minus goes down and plus goes up. Alright, so the shifts that are going to happen from x to the third, which is f of x, to g of x, is 1 unit to the right and 2 units down. Answer to question number 10 is option number 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. We would also like to know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions, comments, or special requests, you can feel free to post it in the comments section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for other cool review tutorials such as this. More resources, worksheets, games, and tools can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.